Alright guys, so we're looking at the warm-ups. We're going to check the answers that they have up there. This was the first problem. We're just given 6x to the fifth, and so taking that derivative, we just have to do k times our exponent, and then subtract 1, and that is correct up there. On the second one, we have it written like this, which makes it a little bit more difficult. So I do have to multiply this out first. So what do we do when we have like bases? What do we do with the exponents? Add them. If you forget, think about something easier. Like if you have x squared times x cubed, and you debate, is that x to the sixth or x to the fifth? We'll write it out. X squared means x times x. X to the third is x times x times x. What's another name for that? X to the fifth. So what do we do when the bases are alike? Add the exponents. So therefore, this is going to be really x squared times x to the 1/2. What do we get if we add those exponents? 5/2. And then another name for 4x square root is going to be 4x to the 1/2. And so then taking this derivative, we're going to have 1 times 5/2 is 5/2 x, subtract 1. 4 times 1/2 is 2x, subtract 1. And so this would be okay, but we really don't want to leave negative exponents. So a better way to write this would be 5/2 x to the 3/2 plus 2 over x to the 1/2. The other thing is, when you check the back of the book, a lot of the times they make the end of the problem match the beginning. So the beginning is in radical form, so they would probably write this in simplest radical form. You might know how I would write x to the 3/2 in radical form, Alex? Okay, but if it's radical x to the third, what would that be? X radical x. So then this could be written as x radical x plus 2 over radical x. And we don't care about having radicals in the denominator. All right, guys, that leads right into what we're going to talk about today. So let's go to the notes. Today we're going to be studying a rule called the product rule for differentiation. The product rule says this. And you really want to watch this closely, what the rule says, because people always make mistakes with this. But what we have to do is if we're trying to take the derivative of two functions that are getting multiplied, the rule is it's going to be the derivative of the first function times the second, plus the first function times the derivative of that second function. Look at it again. F prime, so the derivative of f, times g, don't change g, plus f times g prime. And then I just wrote it out in words. The derivative of a product of factors is equal to the derivative of the first factor times the second factor plus the first factor times the derivative of the second. That's a lot more difficult to memorize than f prime g plus fg prime. All right, let's try it. And here's the big mistake. People think, oh, if I'm taking the derivative of f times g, it's just f prime times g prime. Wrong. That will not work. So it says, find the derivative of each of the following. If a c value is given, find the slope at that point. Here's our first problem. So this would be representing f. This would be representing g. So to find that derivative, I have to do f prime. What is f prime? 6x times g, 2x cubed, plus f, 3x squared, and then what's g prime? 6x squared. So now combining these, what is 6x times 2x cubed? So we have 12x to the fourth plus, what's 3x squared times 6x squared? And what is 12x to the fourth plus 18x to the fourth? Does anyone see how this problem relates to our warm-ups? This is the same answers we got in number 1 in our warm-ups. Why is it the same answer? What do I get if I multiply these two together? 6x to the 5th. Isn't that what our problem was in the warm-ups? So what you want to notice is sometimes you're better off just to multiply out the problem rather than using the product rule. This is a case where we would have been better off just multiplying it out like I had you do in the warm-ups. I just gave it to you, 6x to the 5th, and then we could quickly find the derivative. But I just wanted you to see how the product rule will work on that as well. Now, the whole reason we study the product rule, you might be thinking, well, why don't I always just multiply it out? Because you can't. X squared times sine x, I cannot multiply that out and get rid of the fact that I have a product. This is a product no matter what I do. So I want to identify f. And if you're having trouble with this, I'm going to write it out even more thoroughly this time. My f value is x squared. What's the g then? Sine x. What is f prime? 2x. And what is g prime? Cosine x. And now we just look back at what our formula is. Our formula goes f prime g plus f g prime. And now we're just going to use substitution. What is f prime? 2x. Look for g plus f and then g prime. And so that would now be m prime of x. Okay, questions there? All right, let's take a look at the next one. Do you guys like to write it out like this? Does that help you? Okay, let's write it out then. So what should we call f then? Okay, and let's write it in rational exponent form. So x to the what? Okay, and then what's g going to be? And now let's find f prime. So f prime is going to be 1 times 1/2. Subtract 1. G prime is going to be 2x. And now we can just look over here at the formula. So it's going to go f prime times g plus f times g prime. Okay, now simplifying this is a little bit tougher. So I'm going to write m prime of x is equal to, I have to distribute this out. So if I have 1/2 times 1, that's just a half. What do we do when the bases are alike and we're multiplying? Add the exponent. So what's negative 1/2 plus 4/2? 3/2. Everybody with me on that? I'm adding those exponents. So it's x to the 3/2. And now I have to multiply this times 4. So 1/2 times 4 is going to be 2x to the negative 1/2. And then on this one, I have to multiply these. So these are going to be 2x to the what? Add the exponents. 1/2 plus 1 is 1/2, which is 3/2. Okay, so now look at our terms. Terms are separated by pluses and minuses, or addition and subtraction. So here's one term, here's another term, here's another term. Are any of those terms alike? The first and the last one are alike, aren't they? Okay, so what's 1/2 of these plus 2 of these going to be? 2.5, right? What's 2.5? Another name for that? More than 3 halves. 5 halves. So I'm going to have 5 halves x to the 3 halves plus 2x to the -1/2. Well, didn't we just do this a minute ago? What is another name for x to the 3 halves? 5 halves what? In radical form? X radical x plus 2 over radical x. Do you guys see how this is the exact same problem we just did in the warm-ups? See how if I had multiplied this out, all I did in the warm-ups is I multiplied it out for you. I wrote it as radical x times x squared is x squared radical x, and 4 times radical x is 4 radical x. See how we got the same answers? For that problem, which way was easier, multiplying it out or doing the product rule? Multiplying it out. See, with calculus, it's like you're going to learn a lot of different tools, and you want to use the tool that's best. You can use this document camera to nail in a nail, right? But it's a little bit easier to use a hammer. So that's the type of thing we're thinking of in calculus. What's the best tool to use? I can use the product rule here, but wow, that was a challenge. Just multiplying that out and recognizing that would make things easier. That's what I do. If I can multiply it out, I do it. But I want you to understand that the product rule does always work. All right. Number 4. We look at this. Can we multiply this out? Is there any way to get rid of the fact that I have an x times sine x? No. Sometimes people say, well, why can't I just make that sine x squared? Well, that doesn't make sense because this is using x as an actual value. Like x might be pi over 6. It's not like we're going to do the sine of pi over 6 and then we're going to, multiply that pi over 6 times pi over 6 and then take the sine. That's not what's happening. Okay, so these are completely separate. We cannot multiply them. We have to use the product rule. So in this case, what's our f going to be? X. What's our g going to be? Sine x. What's f prime? And what's g prime? G prime? Cosine x. And now we just plug it in. So we're going to have to do f prime g plus f g prime. And this time we have a c value. So this would be asking me to find the slope at pi over 3. So I'm now finding f prime of pi over 3. So wherever we have an x, we have to plug in pi over 3. What's another name for pi over 3 in degrees? A lot of times we're better off with degrees. 60, do you know the sine of 60 degrees? Radical 3 over 2, good. Plus, do you know the cosine of pi over 3? 1/2 times pi over 3. Well, 1/2 times pi over 3 is going to be pi over 6. Okay? So that's what I think the answer should be. So checking that, radical 3 over 2 plus pi over 6 gives me this answer. I think that's what the answer should be. Now I could go to y equals, and I could put in x sine x And I could do a zoom trig because I have a trig function in there. And now I'm just going to have the calculator tell me what is the slope right there at pi over 3. So second trace calculate the slope at pi over 3. And it tells me that slope right there, it's kind of hard to see, is 1.38. And that's exactly what I got the other way, right? It's the exact answer. So now I know that this is correct. But if I were doing this problem, this isn't the best tool to use because I would always ask you to find the exact answer. See how this is not the exact answer for that derivative at pi over 3. This is. In fact, an even better answer might even be this. I want you to see if you would understand. If this were a multiple choice question, I would write the answer like that. What did I do? Get in what? Common denominator. Okay? So I really don't care how you write your answers. This really isn't that much more less simplified, I guess I would say, than that. But we always get common denominators. Same thing in the back of the book. You check that answer, they're going to have that. Okay? All right, guys, that is it. So